Hello good dear viewers, in this tutorial we are going to apply the knowledge of geometry and calculus to derive the general formula for calculating the area of a cycle given as pi r squared. But before we start, you should know that for every given cycle there is a center, right? And the distance from the center to every part of the circumference is exactly equal, and we call it what? Radius. And what about the area? The area is just the region you can see here, which is bounded by the circumference. And to find it, you can always use this formula, which is pi r squared. All right, now I would like to draw a cycle on coordinates plane. All right, here is a cycle drawn on coordinates plane from the origin, which is also the center of the cycle. And remember I told you from the center to every part of the circumference is exactly equal, and we call it the radius. We have 4 quadrants. I want to pick a quadrant at random, find its area. Whatever I obtain, I'm going to multiply by 4 because we have 4 quadrants. And the total number of these 4 quadrants make a cycle. So let me take the first quadrant here. And we have learned that from the center to every part of the circumference is called radius. So I have a radius here, which is called r. And we can simply form a right angle triangle. Just draw a vertical line perpendicular to x-axis and connect it like this. This is a right angle and this is an acute angle. The vertical distance is called y and the horizontal distance is called x. So what is the relationship between x, y, and r? Remember Pythagoras' rule stated that opposite squared plus adjacent squared is equal to the hypotenuse squared. So what is opposite here is y. Therefore, y squared plus the adjacent, which is x, also squared, is equal to the hypotenuse, which is r, also squared. And this is nothing but equation of a cycle in geometry in standard form from the origin. Now we can write y in terms of x and r by making y the subject. Therefore, y squared is equal to r squared minus x squared if you take positive x squared to the other side. Now let us take the square root of both sides. Square root of the left hand side will eliminate the power of 2. We have y equal to the square root of r squared minus x squared. We don't have to attach plus or minus because we are in the first quadrant. And in the first quadrant, both x and y are positive, right? So this is the function we need to integrate from where to where? From the origin to this part of the circumference, which is radius, because from the origin to this part is radius. So this is what we need to integrate to get the area of that sector. So therefore, the area of that sector will be equal to the integral from 0 down to r of this function square root of r squared minus x squared with respect to x. Okay, remember I told you after obtaining the area of this sector, we are going to multiply by 4 because we have 4 sectors. So from here, I can just attach a factor of 4. So once you integrate this function, you're going to obtain pi r squared. But before we move on, we need to find a relationship that exists between these side lines and our acute angle. The acute angle here is theta. So what can you remember about cosine theta? Cosine theta. It is equal to what? Adjacent divided by the hypotenuse. And the adjacent is x. The hypotenuse is r. So if you want to make x the subject, you can just multiply both sides by r. Therefore, x is equal to r cosine theta. So instead of this x, we are going to replace it with what? R cosine theta. So let's do that. Therefore, our area is now equal to 4 multiplied by the integral of the function r squared minus x squared. This is just x, but we need x squared. If you square both sides, you have x squared equal to r squared cosine squared theta, right? So we have minus r squared cosine squared theta. But we are not going to write dx because our new function is now in terms of theta. Likewise, the boundaries, we are not going to write them as 0 to r. We are going to change them. So let us obtain a term in terms of dx and also our boundaries. What we need to do is to differentiate this function. Let us differentiate it. From left to right, we have dx equal to r is constant, so you leave it as constant. If you differentiate cosine theta, you're going to obtain negative sine theta. So attach negative here, and we have sine theta d theta. All right, so now instead of this dx, we are going to write negative r sine theta d theta, right? But that negative, we can factor it out here and write only r sine theta d theta. So what about the boundaries? We can use this equation cos theta is equal to x divided by r. So let me bring it down here. Cos theta is equal to x divided by r. Remember, when x is 0, we are going to substitute it here to find theta. So when x is 0, what do we have? We have cosine theta equal to 0 divided by r, which is 0. So the question is, cosine of what angle is equal to 0? Remember, cosine depends on what? X coordinate. And we are in the first quadrant. So let's look. In the first quadrant, where do we have x? This is where we have x. And this is also where we have x. So this is where x is equal to 0. And that angle is what? 90 degrees, or pi divided by 2. So we are going to write pi divided by 2 for theta. So we have pi divided by 2. But the top is r. So what happens when x is r? When x is equal to r, we have cosine theta to be equal to what? R divided by r. So I can write it as 1, right? So cosine of what angle is equal to 1? Where is cosine equal to 1? This is cosine equal to 1 in the first quadrant, and this angle is what? 0, or 2 pi. Therefore, theta is equal to 0. So instead of r, we are going to write 0 here. So now let us continue. Let me just copy this. All right. And another thing you should know is that if you want to remove this negative sign, it is as simple as flipping upside down the boundaries. So you can just switch them. The area of the cycle is now equal to positive 4 multiplied by the integral from 0 to pi divided by 2. We just remove the negative sign. And inside, you can see we have r squared in common. So let's factor 1 out. We have the square root of r squared multiplied by 1 minus cosine squared theta. I promise I will not jump a single step. Multiplied by r sine theta d theta. All right. What do you know about 1 minus cosine squared theta? Remember, I said I'm not going to jump a step. Sine squared theta plus cosine squared theta is equal to 1. This is our famous identity. Therefore, sine squared theta is equal to 1 minus cosine squared theta if you make sine squared theta the subject. Therefore, instead of this 1 minus cosine squared theta, which is this, we can write it as what? Sine squared theta. Therefore, our area is now equal to 4 multiplied by the integral from what? 0 to pi divided by 2 of the square root of r squared multiplied by sine squared theta. Sine squared theta. Then multiplied by r sine theta d theta. R sine theta d theta. We are moving. The square root of r squared is r. The square root of sine squared theta is sine theta, because the power of 2 will go, right? So this is a equal to 4 multiplied by the integral from 0 to pi divided by 2 of what? R sine theta multiplied by r sine theta d theta. You can see these two functions are exactly the same, so we can just square them. A is equal to 4 multiplied by the integral from 0 to pi divided by 2 of r squared sine squared theta d theta. And you should know that r squared is constant here because we are integrating with respect to theta. Therefore, we can bring it out. A is now equal to 4 multiplied by r squared as you bring it out, multiplied by the integral from 0 to pi divided by 2 of only sine squared theta d theta. Okay, now we are going to derive another identity. Remember, cos of double angle, cos 2 theta, is equal to cosine squared theta, right, minus sine squared theta. But from this famous identity, which is this one, cosine squared theta is the same thing as what? 1 minus sine squared theta. Therefore, we can say that cos 2 theta is equal to 1 minus sine squared theta instead of cosine squared theta. And we have another minus sine squared theta. Minus sine squared theta minus sine squared theta is minus 2 sine squared theta. Therefore, cos 2 theta is equal to 1 minus 2 sine squared theta. You can bring this one to the left and take this to the other side. We have positive 2 sine squared theta equal to 1 minus cosine 2 theta. You divide by 2, we have sine squared theta equal to 1 minus cosine 2 theta divide by 2. So instead of this sine squared theta, right, we can replace it with 1 minus cos 2 theta divided by 2. Therefore, our area A is equal to 4r squared, which we have outside the integral, from 0 to pi divided by 2. Instead of sine squared theta, we have 1 minus cosine 2 theta divided by 2. But don't forget d theta. 2 is also constant here. Let us bring it out. A is now equal to 4r squared divided by 2 as you bring it out. The integral from 0 to pi divided by 2 of only 1 minus cos 2 theta d theta. And now we can integrate directly. And let's do that. A equal to 4 divided by 2 here is 2. So we have 2r squared, 2r squared. Then multiplied by, if you integrate 1 with respect to theta, you know, if you are integrating a constant with respect to another variable, just replace it or multiply it by that variable. So 1 times theta is theta. The minus. Remember, if you integrate cosine of a function, it is going to give you sine of the same function. But this is what chain rule. We have an inner function. Therefore, we're going to divide by the derivative of that function inside. If you differentiate 2 theta, you're going to obtain 2. We are almost done. The only thing we need to substitute is what? The boundaries. From 0 to pi divided by 2. So now let me start by substituting the upper bound. We have our area to be equal to 2r squared multiplied by whatever we have inside. Instead of theta, we are going to replace it with pi divided by 2. We have pi divided by 2 minus sine of what? 2 multiplied by theta, meaning 2 multiplied by pi divided by 2. The 2's will cancel, leaving only pi divided by 2. Then we subtract the lower bound. And what is the lower bound? 0. Wherever we have theta, we are going to replace it with 0. So this is 0 minus sine of 2 times 0 is 0 divided by 2. All we have to do is to simplify and get our final answer. So A is now equal to 2r squared multiplied by pi divided by 2 minus, what is sine of pi? Remember that pi is 180 degrees. Sine of 180 degrees is 0. So we have 0 divided by 2 is 0. Then we subtract the lower bound. This is 0 minus sine of 0 is also 0. Divided by 2 is 0. So you can see that the whole of these values are 0. The only thing we have is pi divided by 2. Therefore, our final answer is A equal to 2r squared multiplied by pi divided by 2. And 2 will cancel 2 right here. All we have is r squared times pi, which can now be written as what? A equal to pi r squared. Final answer. And hence the area of a cycle is pi r squared. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.